All right, hi. This is an introduction to ELC 343 Lab 2. In this lab, you're going to be using the 7-segment LED. You can see the 7-segment LED there. It's a little bit covered, but maybe I can make it a little more visible, the part that we have. I'll just show you a little bit what it looks like. I mean, you'll notice we have the resistors down here, one resistor for each segment for driving it. And this is what it will look like when you get your program running. It'll go through the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And I've made a little bit of extra fun, so you're welcome to do that. So I just had a little bit of fun with this. Then I go back. So I think I ask you to make each of the characters stay on screen for 2 seconds. I'm showing them on screen for 1 second. You can do either one. It's not critical, 1 or 2. If you want it to go a little bit faster, that's fine. And if you want to do some creative stuff, that's great as well. So what I'd like to do now is just to show a little bit, talk about my design. Let's look at the schematic. There's really not much to it. I just have an output port with 7 pins. And there's nothing there, just uncheck hardware connection and so forth. You'll all figure that out. And then the code is very straightforward. I ask you to write this, this function val2segs. For my own help, I sort of wrote down some things, making it clear where A, B, C, D, E, F, G segments are. And then a mapping for myself of what the values should be. And then the code is really straightforward. I'm not going to even run through the code because it's so straightforward. So that's pretty much all I have to say about this. It's very, very straightforward. The one thing I will say is that driving the LEDs with the common common anode configuration requires driving them active low. So if we, maybe I can pull up the sheet so you can see this is what the diagram looks like for the 7-segment LED. And you will wire the anode to the supply voltage, which you want to be 5 volts in this case, and you're going to wire each cathode to a general purpose input-output to a digital output pin through a 330 ohm resistor, and you should be able to do some figuring out about things there in terms of what the current will be and such. These red LEDs typically drop about 2.1 volts when they're conducting. Different color LEDs have different forward voltages. Red LEDs are about 2.1 volts typically, but whenever you're doing anything like driving LEDs, you should read the data sheets and find out what the voltage is that you'll need. What else is there to say? So we're driving active low, meaning that to turn on a segment, the output, the digital output needs to be a low, needs to be driving a low, which is trying to drive the output to ground, trying to sink current from what's fed into the output into ground. And in the handout, I have some plots of what the voltage current characteristic of a digital output of the PSOC chip looks like, and I ask you to do some things about that, relating to that, analyzing this simple circuit based on that. And I think that's pretty much it. The only other thing to say is that if this was a common cathode configuration, which is also not at all uncommon, where all the cathodes of the diodes, the bottom end of the diodes, were all connected together, that means that you would connect that point to ground, and then you'd be driving all the anodes from the GPIO, and then it would be active high. And I ask you to talk about those things a little bit and explain what's the difference between active high and active low, and why you're doing one or the other. All right, I think that'll do it for now. And good luck with this. And I will end here.